Our brains are essentially prediction machines. They are highly compartmentalized and fine-tuned over millions of years for one primary goal: keeping us alive. They aren't designed to show us an accurate picture of reality, but rather a carefully filtered, highly organized version of it. At the very top of this neural chain of command is a system called the Default Mode Network, or DMN. Think of it as the brain's ultimate executive controller. Whenever you're daydreaming, recalling a personal memory, or imagining your future, the DMN is highly active. It stitches together your autobiographical history to generate the continuous sense of identity you experience as your ego. But an overactive default mode network can trap you. When this firing system becomes too rigid, it creates a mental hall of mirrors. You can get locked into repetitive, negative thought loops, which fuels conditions like depression and severe anxiety. That means our deepest sense of who we are, and sometimes our deepest mental suffering, are tied directly to the physical inflexibility of this specific neural hardware. Operating below the DMN is another strict controller, the thalamus. It acts as a ruthless gatekeeper, blocking out the vast majority of sensory data hitting your eyes and ears to prevent cognitive overload. Lysergic acid diethylamide, or LSD, is a microscopic chemical catalyst capable of overthrowing both of these defense systems at the same time. When LSD enters the brain, it binds to specific serotonin receptors, primarily one known as 5-HT2A. As the molecule slides into the receptor's pocket, a protein structure called extracellular loop 2 folds over the top of it. It creates a physical lid, trapping it. Because it remains trapped, the receptor fires continuously. This single, sustained molecular binding event serves as the catalyst for an hours-long collapse of the brain's entire hierarchical control system. The first major casualty of this cascade is the default mode network. A radical reduction in functional connectivity occurs, and the network begins to drop offline. Key hubs within the network, specifically the medial prefrontal and posterior cingulate cortices, stop communicating in their usual rhythm. As these physical nodes disconnect, the experience of the self fractures, causing ego dissolution, a state where the boundary between individual and universe disappears. For someone in a severe depressive episode, this breakdown interrupts the constant, punishing loops of self-criticism. The hardware enforcing their negative rumination has temporarily gone dark. Ego death is not a mystical metaphor. It is the measurable, physical desynchronization of the brain's highest executive network. With the command structure fractured, the thalamus fails to do its job as a sensory filter. Without that restrictive gatekeeper, a massive volume of raw, unfiltered environmental data floods directly into the cerebral cortex. The brain compensates for this overload through global crosstalk. Thousands of temporary pathways ignite, bridging historically isolated regions. When the visual center communicates directly with the auditory cortex, boundaries blur. This cross-wiring produces synesthesia, allowing a person to hear colors. What we call a classic psychedelic trip is actually the consequence of the brain operating in a flattened, non-hierarchical, and fully integrated state. Eventually, the LSD molecule breaks free from the receptor, but when the chemical exits, the brain does not return exactly to its baseline state. LSD is a psychoplastogen, a compound capable of rapidly inducing structural changes in neural circuits. The intense period of global crosstalk, combined with that sustained 5-HT2A activation, triggers a massive surge of a protein called brain-derived neurotrophic factor, or BDNF. BDNF acts like fertilizer for the nervous system. Under its influence, neurons in the prefrontal cortex and hippocampus rapidly sprout new dendritic spines, forging resilient new synapses. This process converts temporary perceptual shifts into lasting structural changes, building new physical connections that remain long after the molecule has left the system. Because of this neuroplasticity, rigorous clinical trials are moving through the FDA right now, testing these compounds for severe anxiety, treatment-resistant depression, and PTSD. By forging healthy new synaptic pathways, the brain is granted a critical window of opportunity. Patients can escape deeply entrenched maladaptive behavioral loops. By chemically dissolving the rigid networks of the ego and forging new physical pathways, This process proves that human suffering and our very identity are far more malleable than we previously understood. But is it possible that healers and shamans in ancient times knew something that we are just figuring out? High in the Lipes Altiplano of southwestern Bolivia, the landscape is defined by extreme cold, thin air, and an elevation approaching 13,000 feet. Within a rock shelter known as Cueva del Chileno, archaeologists recovered a ritual kit belonging to the pre-Inca Tiwanaku civilization and a unique pouch constructed from the sewn-together snouts of 3 foxes. Testing organic residue from the fox snout pouch using liquid chromatography tandem mass spectrometry revealed 5 distinct molecular peaks. Those signatures correspond to cocaine, its metabolite benzoyl-L-guanine, bufotenine, DMT, and harmine. This is the largest variety of psychoactive substances recovered from a single South American artifact. The presence of 5 different compounds in one container points toward a high level of intentionality, suggesting these plants were chosen for their specific chemical interactions. However, this discovery presents an ecological paradox. The plants required to produce DMT and harmine do not grow in the high Andes. They are native to the lowland Amazonian rainforest. Securing these materials required the use of intercontinental trade networks, specifically established to transport psychoactive botanicals across thousands of miles and vastly different climates. The need for multiple plants is a matter of biology. DMT is a potent psychedelic, but it is inactive when swallowed because monoamine oxidase enzymes in the human gut rapidly destroy it. Harmine, sourced from the Banisteriopsis caapi vine, acts to neutralize those enzymes. This interaction allows the DMT molecule to enter the bloodstream and cross the blood-brain barrier intact. By combining these specific species, ancient South Americans were manipulating human metabolic pathways. They identified a biochemical barrier in the digestive system and developed a targeted bypass to achieve a specific neurochemical state. The bufotenin in the Tiwanaku patch is part of a tradition involving Anadenanthera tree seeds, which were ground to produce the hallucinogenic snuffs, yopo, and cojoba. In Argentina, puma bone pipes used for inhaling these seeds date to 2130 BC, providing the oldest archaeological evidence of entheogen use. Nasal inhalation offers another way to sidestep human biology. By absorbing the compounds through the nasal mucosa, the user avoids the first-pass metabolism in the liver that occurs with oral ingestion. Missionaries and early explorers recorded the rapid onset of the effects, intense geometric visions, and a complete distortion of the sense of time. These cultures developed specialized, non-oral delivery systems to maximize the potency of tryptamines like DMT and bufotenine, showing a deep understanding of drug absorption rates. In North America, this pharmacological record reaches back 5,500 years, evidenced by the recovery of psychoactive peyote buttons from archaeological sites in Texas. In central Mexico, the Aztec people used Tiwanaku, or flesh of the gods, and morning glory seeds for ritual divination, as recorded in the 16th century Florentine Codex. The LSD-like alkaloids in those morning glory seeds are not a product of the plant's DNA. Instead, they are produced by a symbiotic fungus called Paraglandula that lives inside the plant, synthesizing protective alkaloids in exchange for nutrients. This biological mechanism matches how ergot fungi produce alkaloids while parasitizing cereal grains like rye. Mesoamerican shamans essentially utilized an inter-kingdom synthesis, employing fungal metabolites delivered through a higher plant. In ancient Greece, the Eleusinian mysteries centered on a sacred beverage known as kykeon. Initiates reported experiencing ego death and a profound sense of unity, removing the fear of death. A prominent historical hypothesis suggests that the kykeon beverage was prepared using barley infected by the ergot fungus, which contains psychoactive lysergamides. However, raw ergot is highly toxic. Throughout history, it has been responsible for mass outbreaks of St. Anthony's fire, a condition involving gangrene, convulsions, and death. Experimental research shows treating ergot with a lye solution of water and ash breaks the molecule apart. This process, alkaline hydrolysis, cleaves the complex ergotamine into simpler psychoactive amides. This isolates the visionary lysergamades while neutralizing toxic ergopeptides that cause physical harm. If this hypothesis is correct, the Greeks were practicing targeted molecular extractions, isolating a visionary chemical while deliberately removing a lethal toxin. This pattern of identifying and preparing psychoactive chemistry continues into the history of the early Indo-Aryans and their ritual drink known as Soma. As these tribes migrated, the botanical identity of the original plant was lost, leading to a millennia of substitutions and debate among scholars. Based on Rig-Vedic descriptions of a radiant cap with no leaves or roots, researchers have proposed candidates like the Amanita muscaria mushroom or psilocybe species. Others argue for stimulant plants like ephedra or the MAO-inhibiting Syrian rue, reflecting the varied properties ascribed to the drink in ancient texts. The shifting identity of Soma suggests the psychedelic experience was valued as a specific functional state. When the original plant was unavailable, these cultures found new botanical sources to replicate the effect. These three chemical families, the ergolines, tryptamines, and phenethylamines, represent the primary toolset of ancient psychopharmacology. Despite their diverse structures, all three families achieve their effects through the same biological mechanism. They act as agonists for the 5-HT2A serotonin receptor in the human brain. LSD is particularly potent because of its unique binding kinetics. The receptor actually folds over the drug, trapping it inside and extending its influence on the neural architecture. Civilizations separated by oceans and millennia were independently identifying and targeting the exact same receptor in the human brain. Modern pharmacology represents a continuous line of inquiry into human biology that reaches back 5,000 years. November 1938. Inside the clinical pharmaceutical laboratories of Sandoz in Switzerland, a chemist named Albert Hofmann is looking for a simple respiratory stimulant. He synthesizes a new compound from an ergot fungus, labels it LSD-25, and sets it aside after initial animal tests show no medical promise. 5 years pass. In April 1943, a peculiar presentiment leads Hofmann to re-examine the compound. While resynthesizing it, he accidentally absorbs a minute quantity through his skin. He is soon overtaken by a dream-like state, characterized by an uninterrupted stream of fantastic, kaleidoscopic pictures and intense colors. 3 days later, on April 19th, Hofmann intentionally ingests 250 micrograms, what he thinks is a tiny threshold dose. As the world begins to warp, he is escorted home by his laboratory assistant. Because of wartime travel restrictions, they make the journey by bicycle. Pedaling through Basel, Hofmann experiences the world's first intentional acid trip. Hofmann's experience revealed a discovery of staggering potency. Most medications are measured in milligrams, but the reality-altering effects of LSD are triggered by doses measured in micrograms, millions of a gram. This created an immediate scientific vacuum. Society now possessed a molecule capable of dissolving human perception, but there was no existing category or context for what the substance actually was. Sandoz laboratories moved quickly to find a commercial application. They marketed the drug as Dissolution, shipping it to researchers across the globe as a potential psychiatric cure-all. The early clinical hypothesis was that LSD was a psychotomimetic. Doctors believed it briefly replicated the symptoms of mental illness, allowing them to experience and study the inner world of schizophrenia firsthand. By the mid-1950s, researchers like Humphrey Osmond shifted the focus to therapy. His studies achieved success rates as high as 50% in helping chronic alcoholics maintain sobriety for over a year, a result that drew the attention of Alcoholics Anonymous co-founder Bill W. Osmond coined a new term for the drug, psychedelic, or mind manifesting. This was a deliberate effort to move away from the model of mimicking madness and toward using the drug as a tool for therapeutic self-exploration. Throughout the 1950s, the medical establishment operated with the confidence that they had harnessed LSD as a manageable clinical instrument for treating the human mind. But there was a parallel, darker interest. During the height of Cold War paranoia, the CIA covertly purchased the entire world's supply of LSD to investigate its potential for warfare. Under the top-secret Project MKUltra, the agency conducted decades of unethical research. They secretly dosed unwitting citizens, prisoners, and government agents, hoping the drug could function as a mind control serum or tool for breaking prisoners during interrogation. At the military's Edgewood Arsenal, thousands of tests were conducted on soldiers to see if LSD could be used as a non-lethal incapacitant, a way to induce mass hysteria in enemy troops without destroying property. Eventually, the military intelligence complex abandoned the molecule, not because of the ethical violations, but because the drug's effects were too chaotic. It was a chemical that defied the predictability required for a weapon. In the early 1960s, LSD escaped the clinic and the barracks. Harvard professor Timothy Leary began administering the drug to students, advocating its benefits in consciousness expansion. Leary's highly publicized dismissal from Harvard in 1963 turned him into a countercultural figurehead. The drug was no longer just an object of scientific study. It was becoming a spiritual sacrament for a new generation. On the West Coast, author Ken Kesey democratized the experience through his acid tests. These were massive parties that blended drug use with strobe lights, fluorescent paint, and live musical performances. Underground mass production by freelance chemists like Owsley Stanley fueled a cultural revolution. The drug began to alter the aesthetics of visual art, the structure of rock music, and the social expectations of the 1960s. This unregulated surge had consequences. Publicized reports of bad trips, prolonged psychological distress, and personality changes created a wave of public fear regarding the safety of the general populace. By dissolving established social boundaries, LSD had become a symbol of anti-establishment freedom, directly challenging the institutional control that originally sought to master it. The institutional backlash was absolute. Sandoz halted all production in 1965, and the administration of President Richard Nixon moved to outlaw the drug federally. In 1971, the UN Convention on Psychotropic Substances locked LSD into the most restrictive regulatory category, Schedule 1. This legally defined it as having high abuse potential and no medical use, declaring that clinical research was officially over. A global law enforcement crackdown followed, criminalizing users and dismantling the underground laboratories that had fueled the 1960s. For nearly 40 years, this prohibition effectively froze scientific progress. Decades of promising data on alcoholism and anxiety were buried under a legal framework that labeled the molecule a poison. That freeze only began to thaw recently. Since 2009, a quiet resurgence of FDA-approved clinical trials has returned to the questions first asked in the 1950s. This modern research focuses on how LSD acts as an agonist for the serotonin 5-HT2A receptor. In 2024, the FDA designated an LSD derivative as a breakthrough therapy for generalized anxiety disorder. The chemical structure that the global legal system declared a medical dead end in 1971 is now appearing in medical journals as a primary path forward for modern psychiatry. The molecule itself hasn't changed a single atom since 1938. Its history is a record of society's shifting boundaries, reflecting our struggle to balance institutional control with our enduring curiosity about the nature of human consciousness.